This is a refresher for factoring, and we'll be covering some of the polynomials that you may be required to factor in calculus. You probably knew these techniques at one time, but trying to refresh your mind and to remember the various techniques may be becoming a little bit more difficult than you prefer to have happen. So let's go through and look at some of the various types, the ones you see most often. Now, when you look at the types, one of the ones that you see most often is something that looks like this, a trinomial, meaning there's three terms. So if you have a trinomial and it has an understood lead coefficient of 1, which means there's an understood 1 right here, I have 1x squared, then that's one type. So when you learn any technique in any math course, but it's absolutely crucial in the calculus series, you really need to have a list of steps that says, if it looks like this, I'm going to do this, this, and this, and this. If it looks like this, I'm going to do that, and this, and then this. And if it looks like this other thing, I'm going to do something else. So let's look and say, okay, one thing we know right now is if it's a trinomial, with a lead coefficient of 1. Okay, so what if we have a trinomial with a lead coefficient of a 1? Hopefully, many of you remember this. Some of you may not. It just depends on how often you've used it. So if it's of this type, you know that it comes from two binomials. Correct? And the question of what goes in here is you say, well, I need an x squared. And when you learned how to multiply these together, you learned the FOIL method, F-O-I-L. So it'd be the first, outside, inside, last. So the two first terms got your x squared. So there was an x here and an x there. And to find the other two pieces, you would say what multiplies to this last number and adds to this middle number. Okay, so what multiplies to 3? Thank goodness it's just 1 and 3. That's all you got. Okay, so what multiplies to 3 and adds to 4? 1 and 3. Okay, so there's a 1 and there's a 3. And that works. You have to be careful with your signs. We'll talk about that in just a second. So let's say, all right, if we have a trinomial with a lead coefficient of a 1, right, then, and you might want to make a little example in your little list. You say what multiplies to this number, and it doesn't have to be complete sentence list, okay, and adds to this number, and then you put them in here. And it doesn't matter if you put x plus 3 times x plus 1 or x plus 1 times x plus 3, because that's the commutative property of multiplication. You can do that. Now we're going to build on that list. I'll come back up there in a minute. All right. So let's try another one, just so I can show you some of the things you have to watch out for. Okay. Fairly similar. All right. You look at it, it says factor, or you look at it and think, maybe I should factor. So you say, well, what type is it? Well, it's a trinomial, 3 terms, has a lead coefficient of a 1. You say what multiplies to positive 6 adds to negative 5. So the factors of 6 are 1 and 6 and 2 and 3. And you need to have them multiplied to a positive 6, so it has to be the same sign, adds to a negative 5, so it has to both be negative because you're going to add to negative 5 because they're going to multiply to a positive. So negative 2 and negative 3 multiply to positive 6, add to negative 5. So it'd be x minus 2, x minus 3. Now, I want you to contrast that with this one. X squared minus 5x minus 6. See, very similar. Just a slight difference in the signs. So again, what multiplies to 6? 1 and 6 and 2 and 3. But notice that it multiplies to a -6. So to multiply to a negative, they have to be different signs. And it adds to a -5, so you have more negatives than you do positives, so the bigger number has to be negative. And in this case, it's not the 2 and the 3, it's x minus 6, x plus 1. So if you hurry and you don't pay attention to the signs and then work your way through multiplies to negative, multiplies to positive, it's going to get you. Okay, moving on. So what if we have 3x cubed minus 9x squared minus 12x? Now this is something we haven't done. You may already know what we're going to do, but I just want to talk to you for a second. So when you're doing math, if you don't do something, blank is definitely wrong. Okay, so if you leave the answer blank, it's wrong. So you should look at it and go, I don't know this one, but see if there's anything you do notice about it and anything you can do. So you go, well, I don't know what to do with this one, but let's see. Oh, wait, they all have a 3 in common, right? 3, 9, 12 are all multiples of 3. And once you notice that, maybe you'll notice that there's an x. There's an x here. There's an x squared here and an x cubed. They're kind of a little unexpected form because we've been expecting x squared is the lead. So if I factor out a 3x, that would leave me x squared minus 3x minus 4. All right, so don't go, oh my gosh, I don't know that one. Go, well, what can I do with it? So you say, well, I found a 3x. So then we're back to the favorite, does it have a lead coefficient of a 1? All right, and we can say yes. So what multiplies to -4? 1 and 4, 2 and 2. They're different signs, but they have to add to a -3, so you have more negatives. So -4 plus 1. Okay. Now, a lot of times, especially if it's an involved problem, students will just get focused on this part right there. They'll write down this next part, box it in, and the teacher will count off because you dropped your 3x along the way. So please keep up with what you've got as you're going. Right. Now, since that was different, right, than what I originally had planned, which was, what if it's a trinomial with a lead coefficient of a 1? If you're going to make a complete list that covers all of your possibilities, you need to add something in for what if there's something in common to factor out. And that, as you can see, we factored out before we did the lead coefficient of a 1 question. So it needs to go up here and be one of the first things you ask. Is there anything in common to factor out? And if yes, you need to do that. Okay, so I'm building my list as I go. First time you don't ask yourself that question, you'll probably be regretting it. All right, let's look at a couple other types. So let's go x squared minus 8x plus 16. Now, this still fits under the category of does it have a lead coefficient of a 1 and is a trinomial? And that would definitely work. You'd say what multiplies to 16, 1 and 16, 2 and 8, 4 and 4, right? And adds to -8, and you could say, oh, the 2 fourths, right? And that would get you x minus 4 times x minus 4. But there's a specific type that's called a binomial square. This is supposed to be a Q. Okay, binomial square. Now, every once in a while it comes in handy to know this, so let's talk about it as if we didn't know the lead coefficient of a 1 trinomial technique, and we were just looking at it. And the question here would be, does it have a square on each end? Okay, and it's a trinomial. So it's a trinomial, it has a square on each end. X squared is a square, 16 is a square. So we want to know if maybe it's a binomial square. Remember, you had binomials with just little squares on it. Binomial square. We have to check these because you can sometimes be wrong. And what you would do is go, I wonder if it's this. You would bring the x down. You would take half of this middle term and put it right here. And this sign comes down here. Now, since we just factored it the old way, we know that this actually is the answer, but you better check these because teachers who are trying to be tricky, and I'm one of those that does that, if you're trying to be tricky, then it doesn't work out so well. So let's practice checking it. So what you would do, rather than to multiply it all out, is you would say, does this times this, does minus 4 times x doubled, you have to double it, gets you this term up here in the middle, minus 8x. And you go, yes, it does, so that checks. So whether you write x minus 4 times x minus 4, or whether you write x minus 4 squared, it's the same answer. Let's try this one. Now this one does not have a lead coefficient of a 1, but it does have a square on each end. Right, 64 and x squared are squares, 9 is a square. So let's try. If it is a binomial square, and this is a big if. If it is a binomial square, you square root the front, square root the back. This sign comes down here, and you have to check these, right? So 3 times 8x is 24x, and then when you double it, because that comes from the formula for a binomial square, right? That you double the middle, then 3 times 8 is 24, times 2 is 48. Yes, this is the right answer, as opposed to this one. Right. This one also has a binomial square possibility. Remember, it's an if. Big if, because there's a square on each end, and it's a trinomial. So we put an x here, we put a 5 here, we bring down this minus. But we have to check these. So you would have minus 5 times x doubled. Don't forget the double, right? So that's minus 10x. This does not work, right? Because I couldn't retrieve the middle number. So when we go back to our list, and what you constantly do is update your list. So the next case is, does it have a square? Let me start this over. Is it a trinomial with a square on each end? And if you want to put a little example down here to remind yourself of how that works, this is a great place to do that. So you would say x squared plus 10x plus 25. And you would say, well, there's a square on each end. Maybe it's x plus 5, because you take the square root of each end. But you must, and you need to put this in your list. Okay, anything that's important, that it only works when, or only if, or never when this happens, or always have to check these go in your list. So what you do is you take the back times the front, and you go 5 times x doubled. Okay, that's 10x. It looks good. Right. You don't learn how to do these problems over here. So these problems that are actually worked out, you don't study for the test this way. You practice these problems enough to get comfortable enough with them and proficient and to be able to be accurate with your process. But when it comes time to study the test, you learn the list, okay? And then you practice the list with some problems to where you have confidence in the list. And then when you take your test, the list is in your head and it'll be just fine. Right, on to another technique. Let's do this one. My students always like this one the best because I think it's just kind of cute myself. All right, this is called the difference of two squares. Right? It is not a trinomial, and it just sort of stands out, right? You've got a square here, square there, and it's the difference because it's got a minus in between. Okay, so the difference of two squares. And these came from what's called conjugates, so that the binomials, since you said squares, just like up here when you said squares, you took the square root. Since you said squares, you're going to take the square root. What's the square root of x squared? X. What's the square root of 49? 7. And conjugates say they look an awful lot alike, like these two, but one of them's plus and one of them's minus, and it doesn't matter if it's minus and then plus or plus and then minus. They come from conjugates, and this is the answer, right? So let's try this one. Oh, let's do a different type, and then we'll come back. X squared plus 100. Now this is the sum of two squares. Right, whoops, 100 looks kind of bad. All right, there. So you look at it and go, well, it's not a trinomial, it's a binomial. It's the sum of two squares, and the sum of two squares does not factor, unless there's something in common. Now, I haven't really been saying this over and over and over because I made the problems up, but when you're working a test and it's important and you're being graded, then remember the first question out of your mouth, it should be, is there anything in common to factor out? Because let's say it was 2x squared plus 200, right? If that was the problem and your teacher says to factor it, it doesn't seem to be any type because 200 is not a square, 2 is not a square. But if you always start off with, is there anything in common to factor out? There's a 2. And in this case, you cannot say it doesn't factor. It doesn't factor any further. But it did factor because you got a 2 out. You factored out a 2. So be sure that that's at the top of your list. So if it looks like anything other than a lead coefficient of a 1, you need to say that, right? So let's look at 16x squared minus 81. And let's start practicing that. All right. So you look at this and go, well, that's kind of unusual. Is there anything in common to factor out? Well, 16 will go into 81. Factors of 16 are 2, 8, and 4. Doesn't look like that goes in 81. But it is the difference of two squares, right? Because it's a subtraction and a square on each end. So since you said squares, you're going to take the square roots. What's the square root of 16x squared? 4x. What's the square root of 81? 9. One of them's plus and one of them's minus. All right. You okay so far? Now, let's try a variation on this. What if it looked like 16x to the 4th minus 81? That should be an 81. Nothing in common to factor out, so you take the square root of each one because you would say it's the difference of two squares. So what's the square root of 16x to the 4th? 4x squared. What's the square root of 81? 9. One's plus and one's minus. Now, 4x squared plus 9, this one right here, that's the sum of two squares. There isn't anything in common to factor out, and so that is not going to factor any further. 4x squared minus 9 is still that difference of two squares pattern because it's not a trinomial, nothing in common to factor out, but it's the difference of two squares before again. And so this 4 right here sort of is a hint that it may factor twice. All right, so then you have your 4x squared that you don't want to lose. 4x squared plus 9. 4x squared minus 9 is the difference of two squares again. So what's the square root of 4x squared? 2x. What's the square root of 9? 3. One's plus and one's minus, and this right here is completely factored. All right, y'all try 4x squared minus 16. So stop the video and try that one, see how you're doing, and then restart. So now that you're back, hopefully you stopped and actually did that. If you said 2x plus 4, 2x minus 4, I would be taking off a couple of points because it's not factored completely. Now, 2x plus 4, 2x minus 4 is not wrong yet. It's just not finished. So there's a 2 in common in this first factor, 2 times x plus 2. And there's a 2 in common in this second factor, 2 times x minus 2. And then these 2's make 4, and you have x plus 2, x minus 2, which is now factored completely. But let's go back and look at the start. If you always start off with, is there anything in common I can factor out? That's a good habit to get into, because if you had looked at that, you would have said, oh, 4 is in common, so let's factor out the 4, and that would leave you x squared minus 4 immediately. And you would go, oh, and that's the difference of two squares, so the square root of x squared is x, the square root of 4 is 2, one's plus and one's minus, and you get there more directly, and it would be less likely that you would accidentally leave these 2's in common. All right, so try to put that as the first of your list every single time. So let's do another one. Let's do 27x cubed minus 64. Now, this is not the difference of two squares. 64 is a square, but it's also a cube. But see this little cube right there? That's sort of your hint that it's not squares. Unless, of course, there had been an x right here, and then you could factor it out, and then maybe it might have worked some other way. But this is sort of your visual cue. Oh, before we move on, let's go back up here. Getting ready to teach you a bad lesson. Let's go back up here. Very start. Okay, so we have a square on each end. What if it's the difference of two squares? And you would say, you know, like x squared minus 25. Then you need conjugates. Using the square roots. Okay, so you would have, here's your conjugates, square root of x squared is x, square root of 25 is 5, one's plus and one's minus. And then you need a note that says the sum of two squares does not factor unless there's anything in common, and that's not really part of the sum of two squares. But don't forget to put that in there. Let's go down, way down here. We're way down here now. And this is the difference of two cubes. Now there's a sheet that should be referenced at the end of the video where the description is, that actually summarizes all this for a list, but it's a good idea for you to make your own list. Don't memorize my list, make your own list. So if it's the difference of two cubes, you should, first thing you need to do is to show me what you cubed. Okay, so you cubed 3x and you cubed 4. I love 64 because it can work as a square or a cube. A lot of teachers like that one too. All right. So you see how when I say show me the cubes, then what you do is you take the cubed root, right, and you show me the cubes. Then you're going to drop the cubes, because if you remember, sum and difference of two cubes had a binomial times a trinomial as their factors. So you drop the cubes, bring down the 3x, bring down the 4, bring down this minus. So this comes down, this comes down, this comes down. Okay? So show me the cubes, then drop the cubes. Okay? You take the term in the front, square it, and put it in the front. You take the term in the back, square it, put it in the back. Okay, take the term in the front, square it, put it in the front. Take the term in the back, square it, put it in the back. Front times the back goes in the middle, so this is 12x. Other styles, you double it. You do not double it here. Okay, so take the term in the front, square it, put it in the front. Take the term in the back, square it, put it in the back. Front times the back goes in the middle. Whatever this sign is right here, this is the opposite. This is always positive. So this sign is always positive. This sign is the opposite of whatever this sign over here is. And you may have heard it in your past life as somebody called it so same, opposite, always positive. All right, let's do another one. What if it's the sum of two cubes? It should be 8. Now, the sum of two squares does not factor, but the sum of two cubes does. So first you show me the cubes. The cubed root of 8x cubed is 2x. The cubed root of 125 is 5. So show me what you cubed. And you're going to build this binomial and trinomial. So the 2x comes down. This 5 comes down. This plus comes down. So you show me the cubes and then you drop them. All right? You take the term in the front, square it, and put it in the front. You take the term in the back, square it, and put it in the back. Front times the back goes in the middle. Okay? If this sign is a plus, this sign is the opposite, and this sign is always positive. So this is always positive. This is the opposite of what's in the binomial. Okay. Let's go all the way back up here. All right. What if it's the sum or difference of two cubes? Okay, you show the cubes, show what you cubed, show the cubes. Drop the cubes, drop the cube powers, the cube powers. To make the binomial. Okay, so this is going to go in there. And then to make this trinomial, you take the front and square it. Take the back and square it. Right in here is the front times the back. This sign is the opposite. This is always positive. Now that's kind of messy, but like I said, there's a sheet that sort of has this all written out for you that I've provided a link to. Okay, let's not go all the way down there. It's going to take forever to scroll back up. Let's do one right here. Now, this is really sort of how you should be learning this list. Okay, so let's get started. You would look at it and go, oh, it says factor, right? Is there anything in common I can factor out? No. Is it a lead coefficient? Is it a trinomial, a lead coefficient of a 1? No. Does it have a square on each end? No, because 3 and 10 are not squares. It's not a difference of two squares, sum of squares, difference or sum of two cubes. All right, when all else fails, and every teacher that y'all had has a different way to do this. I've heard things called the amazing method, the magic method, box method. I have no idea what method your teacher called it. When most of your teachers first learned how to do this type, they called it the trial and error method, which I actually like. But the name is a nice way to say you try it, and you're wrong. Okay, I always thought the name was really cute. You try it, you're wrong, then you try it again and you're wrong, and you try it again and you're wrong, and then finally, you try it and you're right. So the trial and error method said just take your best guess. And actually, once you learn the tricks, it's pretty fast, okay? But I'm going to show you a method. Some people call it the front times the back. Some people call it the A times C method. I'm not sure what it calls it on the sheet. So, because I've called it so many different things in my life, right? But you take this front number times the back, and which is 30. It's a positive 30. And you say what multiplies to 30 and adds to 17. So do you see how it's kind of a version of the lead coefficient of a 1, where you say what multiplies to the end number and adds to the middle? But instead of multiplying to 3, you take the front number times the back number and multiply to that. So 1 and 30, 2 and 15, 3 and 10, 5 and 6. Now this method works so well that if you pick the wrong pair over here, it's going to factor. It's just going to be the wrong factors, and you wouldn't notice it until you checked it. So be absolutely certain you spend most of your time being positive you have picked the right pair over here out of these possibilities, because it is going to factor whichever pair you pick. It'll just be the wrong numbers. You should try it and see how it works. Okay, now I need these are the numbers that multiply to 30. And I need to pick a positive 30. And I need to pick two numbers that multiply to 30 and at the same time would add to 17. Now, can you see them? This is supposed to be 10. All right, so 1 times 30 multiplies to 30 but adds to 31. 3 times 10 multiplies to 30 but adds to 13. 2 and 15 multiply to 30 and add to 17, so that's the one I want. So what you do is you pick your pair. And then you're going to stretch this right here. And you're going to say, this is my 2x plus 15x, because those are your two numbers. And you pick up the variable plus 3. It does not matter whether you put the 2x or the 15x first. So you would say, now you're going to do factoring 4 terms by grouping. So what's in common in the front 2 versus what's in common in the back 2? So you're going to factor by grouping. What's in common between a 10x squared and a 2x? Well, there's a 2 in each one and an x. And when you factor that out, that would leave you 5x plus 1. What's in common between a 15x and a 3? 3. And you use this sign. So if that sign in the middle is a negative, you're going to pull the negative. But this is a plus. So you'd go plus 3, 5x plus 1. If these two things don't match right here, that's your clue that something's wrong. Okay, you've done something wrong. This is not the right technique or whatever. So these two should match. And now you have two very compound terms. There's 2 terms now. What's in common between the front and the back? They both have a 5x plus 1. And that leaves me this 2x and this 3. Okay? Now, just to show you, what if you had put 10x squared plus 15x plus 2x plus 3? So right here in this step, if I had reversed them, let me show you what happens, because this happens and you need to know what to do. So you would look at it and go, what's in common in the front 2? They both have a 5 in common. They both have an x. So that would be 2x plus 3. Okay? What's in common in the back 2? Well, there's nothing in common between a 2x and a 3 except a 1. So you have to factor something out, even if it's only a 1. This is essential that you know this. Okay, so I'm going to factor out a 1, and that would be 2x plus 3. So something has to factor out, even if it's just a 1. And you would go, what's in common in the front and the back? 2x plus 3, leaving you this 5x and this one, which is the same as this, just switched around, which is that commutative property of multiplication. So y'all can stop this next problem and see how you're doing, and then come back and check. But we're going to go through the list. Anything in common to factor out? No. Trinomial with a lead coefficient of a 1? No. Difference of 2 squares or sum of 2 squares, cubes or anything? No. Okay, so we're going to do whatever method it is that your teacher taught you, the front times the back, A times C, amazing method, box method, whatever. So we're going to take 12 times negative 7, which is negative 84, and we're going to find what multiplies to negative 84 and adds to negative 8. So y'all stop and try to figure that out and come back in just a second. Now, if you go through here and do these really quickly, you should have had something like, these are the numbers that multiply to 84. But since it's multiplying times a negative, to a negative, one's plus and one's minus, right? Because of this, one's plus and one's minus, and it adds to a negative 8, so you have negatives left over, so the bigger number's negative. Okay, so remember, you have to spend your time picking this pair, because if you pick the wrong pair, it's still going to give you a factors. It's just the wrong ones. They won't be right. Your teacher will mark it all wrong. All right, so which pair multiplies to negative 84? They all do, right? But adds to negative 8. Okay, how about this one? So again, you stretch it out, and you're going to stretch out this term right there with plus 6x minus 14x minus 7. It does not matter which order you write them down. So what's in common in the front two? They're both even, and they have an x. So you'd have 6x. Okay. Plus sorry, didn't get the biggest one out. How about 6x? That'd be 2x plus 1. And if you caught that faster than I did, look at you. All right. Okay, 2x plus 1. What's in common in the back two? Minus 7. Now, you have to factor out this sign. So when you factor out a negative 7, this is a positive 2x. But a negative 7 factored out of a negative 7 is a plus 1. Remember, you have to be able to distribute this and get back up to here. These two have to match. The 2x plus 1s have to match. That's kind of your double check. So what's in common in both the front and the back is a 2x plus 1. And this is 6x minus 7. And now you're done. All right? So I have no idea what you want to put here. I kind of like to have a sense of humor, on my list, because you got to smile once in a while to stay sane. So if all else fails or something, y'all do whatever. And it's a trinomial. You do the A times C method, or you might call it the front times the back. Or y'all might have the box method, etc. Whatever it is that you call it, all right? Now, like I said, there's a link also to an attachment, which is just a copy of my list I gave my students one time. So it's down there too if you want help coming up with the steps for here. But since I don't really know what method you're going to retrieve from your memories, we're just going to stop this right here. So good luck reminding yourself how to factor, and then go back and do some more limits.